All right, guys, so here we are on our second lesson. This is over measuring and constructing segments, or the distance formula. So we're going to look at the distance formula on a number line and on the coordinate plane. So I'm going to try to keep this as short as possible. So here we go. All right, so the first thing we're going to look at are the formulas for a number line. It's called the ruler postulate. So let me get this thing. All right, so here we go. So the formulas are, that is the absolute value. So these are the absolute value of x2 minus x1, or big number minus small number. Honestly, the way I see it is, so to find the distance on a number line, it's going to be your first number minus your second number, and then it's the absolute value. So whatever comes first minus whatever second. No matter what, you're going to get the same answer. So if it says to find the distance of AD, so A is at -3, D is at 5. So you're going to go -3 minus 5, because it's the first minus the second, and then the absolute value. So if you have -3 minus 5, that is -8. The absolute value of -8 is 8. So the distance from A to D is 8. And yes, I am very aware. I can come up here and I can just count the spaces. 1, 2, 3, 4, 5, 6, 7, 8. But if you're on a number line that has really large numbers, or don't have one to actually count the spaces, then you're going to want to be able to make sure you can use this formula right here. Then that way you don't have to worry about counting spaces that don't exist. You can just plug it in. All right, so the second one here, so CB, so they want the distance from there to there. So I'm going to do first number minus second number. So the first number is 1 minus the second number is 4. 1 minus 4 is -3. And then the absolute value of -3 is +3. So remember, no matter what, your answer is always positive. So over here, make yourself a note. No matter what, your answer will always be positive. Okay, so no matter what, your answer will always be positive. So let's make that a little smaller. And there we go. Okay, so no matter what, your answer will always be positive. And it will always be positive because distance cannot be negative. Even if you walk in reverse, you're still walking a positive distance. All right, so let's look at this next one. It says, find the distance from point E at 7 to point F at 1634. So this is what I was talking about. There's no number line, and I am not going to count individual spaces from 7 to 1634. That is just insane. So I'm going to do first number minus the second number. So my distance here is the 7 minus 1634. And it's the absolute value. So I need the absolute distance, which means absolutely positive. So from 7 to 1634 is negative 1627. And the absolute value of negative 1627 is 1627. So your answer has to be positive. So you would have to take 1,627 steps to get to your destination. All right, our next concept, this is segment addition postulate. So the segment addition postulate, when point B is between 2 points, A and C, so point B is between, if B is between A and C, then AB plus BC, so this piece plus this piece is the whole piece. So this is what we call part plus part. So one part plus the second part equals the whole part. Okay, so what that looks like is if I were to take this part here, so DE plus EF, so this first part plus this second part equals the whole part. So between does not mean the middle, okay? It can be, but it doesn't have to be. So obviously 23 and 35 are not in the middle, all right? So 23 plus 35 equals 58. So that means that DF is equal to 58. And that is your answer. All right. So what happens when I throw a little algebra at you? Well, what we know for a fact, because this right here tells me part plus part equals whole. So part plus part equals whole. So the first part is xy. So xy plus the second part is yz. And that equals the whole part, which is from start to finish. So that is xz. And what I know is that xy is 3a. So I'm going to trade colors again because I like to go in steps here. So 3a plus the second part is 14. And it equals the whole part, which is 41. And if you think back to that little algebra review, this is very similar to that. So if I'm going to take, so 3a is what I do last. So I'm going to take the 14 and subtract from both sides. So I've got 3a equals 27. And then I'm going to take and divide by 3. And I find out that a is 27 divided by 3, which is 9. So now I know that a is 9. Now it says to find xy. Well, xy is this piece right here. So a is 9. So xy is 3 times 9, which is 27. So my final answer here is 27. All right. So now what happens when there's no picture? Well, when there is no picture, that goes into that can you follow the directions and draw the picture scenario that we had the other day. So it says points P, Q, and R are collinear. So remember, collinear means they are on the same line. So if I were to draw a picture with points P, Q, and R, where Q is between. So it didn't say where, it just says between. So I'm just going to put Q right there. So it says that PQ, which is this first part, is 4x minus 20. QR, which is the second part, is 2x plus 30. And PR, which is the whole thing, is 100. So from here to here is 100. So what I know is that statement said part plus part equals whole. The first part is PQ. The second part is QR. The whole part is PR. So PQ is 4x minus 20. QR is 2x plus 30. And PR, which is that whole thing, is 100. So now, just like in our algebra review, we're going to combine like terms and move things around. So the first thing I want to do here is add my x's. So I've got 4x plus 2x, so that's 6x. Negative 20 plus 30, so that means 30 minus 20 is 10, equals 100. So I'm going to subtract 10. So 6x equals 90. Then I'm going to divide by 6. So x is 15. So I know x is 15. So it says to find the value of QR. Well, QR is this piece right here. So that means 2 times x plus 30. And we just said that x is 15. So I'm going to put a 15 right here. So 2 times 15 is 30. And we have that 30. 30 plus 30 is 60. So, oops, that's QR. So that means that QR is 60. Well, guys, if this piece is 60 and the whole thing's 100, this piece has to be 40 because they have to add up to 100. So easy peasy. All right, next concept. So this is talking about congruent segments. I mentioned this the other day. I talked about those little tick marks that are on the line segment. So when you see these, you know that they have the same length. Okay, so I know that AB is equal to CD. If the segments are congruent, so if the segments are congruent, you're going to put the little marks over them with a congruent symbol right here. Okay, so equal means I know the number length of these. Congruent means I know they're the same size, I just don't know what size they are. Okay, so basically just look for those matching tick marks because that means they're going to be the same size. Okay, so the congruent, so matching tick marks. So matching tick marks mean equal size. All right. Next thing here, this is the distance formula, okay? This is the distance formula. And this is for the coordinate plane, okay? So this is for your coordinate plane. The first distance formula I showed you, the first number minus the second number, that's for only a number line. So coordinate plane. So this is the formula for the coordinate plane, okay? So no social distance. No social distance, okay? Bad dad joke. All right, here we go. So we got 2 problems left. So we're going to find the distance between each pair of points. Well, the first thing you need to make sure that you're doing, and remember guys, if I'm going too fast, hit pause, hit rewind. That's the beauty of this. So we want to take and label this. So this is x1, y1. This is x2, y2. So what I'm going to do is I'm going to take and write down that formula. So x2 minus x1 squared, y2 minus y1 squared, and then we're going to take the square root, all right? So x2 is 4, so these are my x values. So I'm going to take and plug them in. 4 minus negative 3. Do not forget this is negative and the formula has a negative, so you have to have 2 negatives, all right? Then my y values are negative 1 minus negative 2. So just plug them in. 2 negatives make a positive, so 4 plus 3 is 7. 2 negatives still make a positive. So this means 2 minus 1, which is 1. And always keep parentheses. Do not lose the parentheses until you have squared your number. Otherwise, it can cause you to get a wrong answer. So 7 squared is 49. 1 squared is 1. So that is going to be the square root of 50. And we're just going to leave it like that because we're not using calculators yet. So the square root of 50. If we had a calculator, it would be 7.07 would be our distance. But we're going to leave it as the square root for now. Okay. Now, please keep in mind, if you're on a grid, you can do the exact same thing. All right. Now, the only difference is if I wanted, I could draw some lines here and create a horizontal and vertical line, which would create a right triangle. And we all learned about Pythagorean theorem, which you could use instead of the distance formula. So I'm going to do both ways, and then we're going to be done. All right. So this point is negative 2, 1. This point is 5, -3. So I'm going to do distance formula first because when you're on a grid, it's so much easier. So this is 1, 2, 3, 4. So this has 4 spaces. This is 1, 2, 3, 4, 5, 6, 7 spaces. So the distance would be 4 squared plus 7 squared. You remember we did this in the warm-up. 4 squared is 16, 7 squared was 49. And then we add those two together and we get 65. So we got to take the square root. So our distance is the square root of 65. Again, we're going to leave it like this, but if we had a calculator, then we would find out that this is 8.06. So it's a little over 8 units from here to here. So now what I want to do, I'm going to do this problem again, but this time I'm going to use these points. All right, so if I were to plug them in, and let me trade colors. All right, so the formula is the same thing up here. So if I said this is x1, y1, and this is x2, y2, so x2 is 5 minus -2 squared. Now y2 is -3 minus 1. So -3 minus 1 squared. And put that there with my little equal signs. All right, so I'm going to scroll up. So 2 negatives make a positive. So 5 plus 2 is 7 plus, and that's -4 squared. All right, 7 squared is 49. -4 squared, so that means -4 times -4 is 16. And if you'll notice, it's the same numbers, 16 and 49. So we still get the square root of 65, which is still 8.06. So we are going to practice this in class and get our assignment done in class. So I will see y'all later. Have a great day.